Welcome to the third section of Chapter 9, where we're going to talk about circles. Remember that in this chapter, we're talking about conic sections. So far, we've talked about parabolas in the last section. In this section, we're talking about circles. So this should be mostly review based on geometry. In geometry, you talked about the equations of circles and graphing circles. So we're just taking it a little bit farther this year, but it should be a pretty straightforward section. So the new vocabulary you need to be on the lookout for, or well, it's not really new since it's about circles, but the word circle, center, and radius. Okay, so a circle is the set of all points in a plane that are equidistant, or the same distance, from a given point, which is my center. So all of the points that are the same distance from the center make a circle, and of course the radius is any segment that has its endpoint at the center and on the circle. So that would be a radius. My center is again defined by HK. The point on my circle is XY. So here they're showing us how we get the formula of a circle, basically. If X and Y are my points on the circle and HK is my center, then the radius is R, so the distance from the center to the edge, the distance from HK to XY, would be used by this distance formula, right? Here they're saying that my x1 and my y1 are h and k, and my x2 and my y2 are x and y. And then when I square both sides to get rid of the square root, I have the radius squared is equal to x minus h quantity squared plus y minus k quantity squared. So that is the familiar formula of a circle that you should recognize. So the standard form of my equation, notice I have two columns here. This column, my center is at 0, 0. So it's just x squared plus y squared equals r squared, easy. This one, my center is not at 0, 0. My center is hk. So I have x minus h quantity squared plus y minus k quantity squared equals r squared. But this is way less complicated than the formulas for parabolas. Okay, so we're going to start out with a practice problem where we are going to write an equation when we're given the radius. So the plan for a park puts the center of a circular pond that has a radius of 0.6 miles, 2 miles east and 3.8 miles south of the park headquarters. We're going to write an equation to represent the border of the pond, so the edge of the circle. Right? The headquarters we're going to assume is at 0, 0. So the center of my pond is 2.5 to the right, because it said 2.5 miles east. So if we're thinking about the XY plane, that would be to the right. And 3.8 miles south, that would be down from the park headquarters, which we're assuming is at 0, 0. So here's my equation of a circle in general. X minus 2.5, because 2.5 is going to be my h, and negative 3.8 is going to be my k, because that's the center of my circular pond. So I have x minus 2.5 quantity squared and y plus, because it's y minus negative 3.8, quantity squared equals the radius squared. So 0.6 is the radius of my pond, and I square it. Then I just simplify. That's the equation of my circle. That would give me the equation of the edge of my pond. All right, so now you guys try this one, please. Here you should have gotten C as your final answer. And that comes from the information that we're given. The radius is 0.5. So I know my equation has to be equal to 0.5 squared. So I know it'll either be A or C, because 0.5 squared is 0.25. 3.5 miles west, that gives me negative 3.5 as the x-coordinate of my center. And 2.6 miles north, so that's positive, or up 2.6. So this is my center, H and K. So I have x plus 3.5 quantity squared plus y minus 2.6 quantity squared equals 0.25. All right, now this time we're going to be given a graph, and we're going to write the equation based on my graph. So if I look at this graph, I know my center of my circle is at 0, 3, so that's my h and k. And my radius goes from 0, 3 to 7, 3. So how long is this radius? Well, we could do the distance formula, but because it's just a horizontal line, I know that that is 7 units long. So my radius is 7 units. So here's the standard form of the equation of my circle. One second. Oh, I see what they're doing. They want you to pretend that you don't know the radius, I guess. But that's okay. So they're using the 7 as x and your 3 as y. So that point that was on the edge is the point 7, 3. And then my center, which is hk, is 0, 3. So they're having us plug in to solve for the radius. So they plugged in my x and y here and my h and k here. And so then when I simplify that, I get 7 squared plus 0 squared. So we still end up with 49 equals r squared. So r is 7. R squared is 49. Notice here they wrote my equation with x squared. This is really x minus 0, quantity squared, but x minus 0 is just x. Y minus 3 because k is 3. And then the radius squared is 49, which we saw here. And we could have figured that out from the graph pretty easily. But if it was a situation where you could not count your radius and you just knew the point, then you would have to do it this way. All right, try this one from this graph. Write the equation. All right, your answer is D, and here's the work. Here's the work to get the radius squared. That, of course, means that my radius would be 14 units. Again, this is an easy one to count, but when I square it, I would get 196. Again, if this point was not an easy point to count the length of the radius, if you didn't know the length of the radius, this is the process you would have to use. H and K for the center, a point xy, and then plug in to find the radius. Okay, this time we're being given the diameter instead of being given the radius. So we're given the diameter. We know the radius is half of the diameter. They're giving me the endpoints of the diameter. So if I think about a circle, think about my diameter, I know that my center is going to be the midpoint of the diameter, right? The center has to be halfway along the diameter. So first I'm going to do that. What's the midpoint between these two points? And I end up with 4 halves and 6 halves, which is 2, 3 as my center. So that's the halfway point. That's the midpoint of that segment because those are the diameter endpoints. So now I know my center is 2, 3. Now I'm going to find the radius. I'm going to use the distance formula from my center, which is 2, 3, or hk. And I'm going to use another point on the circle. Here they're choosing the point 2, 8 as another given point. You could have chosen the other endpoint of the diameter. It wouldn't really matter because it's going to give you the same length of the radius no matter what. So in this case, we do distance formula, 2 minus 2, quantity squared, so that's 0 squared. 3 minus 8, quantity squared, so negative 5, quantity squared. That gives me the square root of 25, or 5 as my radius. So the radius is 5, r squared is 25. So I substitute into my form for a circle, x minus h quantity squared plus y minus k quantity squared equals r squared. And this is my result. 2 was my h, the x coordinate of the center, k is 3, y coordinate of the center, and r squared is 25. All right, try the same thing with this one. The answer here was A. All right, here's the work for this. Here I'm getting the midpoint to get my center. And here I use the distance formula. I chose to use my center, 3, negative 1, and then the point 3,5. So I use the distance formula to get the length of my radius, and the radius squared is 36. So that's what gives me this answer. All right. Remember that circles are perfectly symmetrical, so when I'm graphing, I usually don't have to find too many points before I can get a pretty good graph of a circle. So in this case, I'm given this equation. So from the equation, I'm going to find the center and the radius, and I'm going to graph. So obviously here, the center is 0, 0, because I can't see my h and k, but remember this is like saying x minus 0 quantity squared plus y minus 0 quantity squared is 16. Remember, 16 represents the radius squared, so the radius is 4. And then you make a table of values to figure out some points for this equation. So if x is 0, right, so if I'm plugging into this equation, right, if I plug in x equals 0, I get y equals 4. If I plug in x equals 1, what I'm doing is 1 squared plus y squared equals 16. That gives me y squared equals 15. So y is the square root of 15. I don't need the plus or minus. For this table, we're just getting the positive point right now. And so on. So these are a bunch of coordinates that are on my circle. The circle is centered at the origin. Its center is 0, 0, so it's going to be symmetrical over the y-axis. So that means that if the point 1, 3.9 is there, that the point negative 1, 3.9 is there. It helps sometimes to draw it out. So if I think about the point 1, 3.9, if this was here, I know my circle has to be symmetrical over the y-axis, so the same point has to be over here at x equals negative 1, but it has to have the same y height, and so on with the rest of the points. And this circle is also symmetric about the x-axis, right? So if I have the point 1, 3.9 over here, then I know the same point has to be reflected down here, so it's 1, negative 3.9. And I can do that all the way around in my quadrant. So if I graph these points with the center at 0, 0 and a radius of 4, here's my point 4, 0, there's the point 0, 4, and here in the middle, I have all those other points. 1, 3.9, 2, 3.5, 3, 2.6, and then I reflected them all the way around. The more points you graph, the better your circle looks. It's hard to draw a beautiful circle with just the 4 radius points that you can get on the axes. It's better to get several points and reflect them so that your circle is more beautiful. Okay, but here we have a circle at 0, 0 with a radius of 4. So you try this one. All right, the center in this case was 0, 0. The radius is 3. And if you were to make a table of values, which we're not going to do right now, but you should have on your notes like we did in that example, your table of values should reflect some points in the first quadrant that you were able to reflect around the y and x axes to graph the rest of the points. All right, last example. Graphing an equation that is not in standard form. This is going to be a common theme with all of our conic sections. We're going to have to complete the square to put them in standard form. So here we want to find the center and radius of a circle that has this equation. This is not in standard form. Remember, for standard form, we need to have x minus h quantity squared, y minus k quantity squared equals r squared. So I need perfect square binomials, or perfect square trinomials factored into binomials on this side of my equation. So we're going to complete the square here on x and y. This is going to get fun. So I'm going to have 2 completing the squares happen. So notice I'm grouping together my x terms, x squared plus 6x. And then I have the only y I have is a y squared, and I moved my 7 to the other side. My y squared is actually already complete because this is like y minus 0 quantity squared, and there's no other y term. So I don't have to worry about completing the square on the y squared this time, but I do on x because I have x squared and 6x. So I need to turn that into a perfect square binomial. Half of 6 is 3. 3 squared is 9. So I need to add that to both sides. Why did I do that? Because x squared plus 6x plus 9 is x plus 3 quantity squared. Again, my y in this case I didn't have to worry about. It's just y squared already, equals 16. So this is now the standard form of my circle. My center is at negative 3, 0, and the radius is 4. And again, you would make a table of values to graph that. Okay, so you guys try the same thing here. In this case, you are going to have to complete the square on x and y because I have a plain x term and a plain y term. All right, the answer here is C. I'll show you the work for that. So I'm going to make sure I arrange my equation so that my x and y terms are together. I moved my constant to the other side. Half of 8 is 4. 4 squared is 16, so I'm going to have to add a 16 to both sides. Y squared minus 4y, half of negative 4 is negative 2, squared is positive 4. So I'm going to have to add a 4 to both sides. Why do I do that? Because now x squared plus 8x plus 16 is x plus 4 quantity squared. And y squared minus 4y plus 4 is y minus 2 quantity squared. And then on the right-hand side, I have negative 11 plus 16, which is 5, plus 4, which is 9. Sorry, I should have used something besides green there. And so I can see that my center, h, will be negative 4, and k will be positive 2, and my radius will be 3. All right, I will see you guys in class to practice circles.